Hi students, welcome to my channel. In this video, we are going to discuss asymptotic notations used to say the time complexity. Time complexity is represented by using these three notations: big O notation, omega notation, theta notation. Okay. So, you know already what is meant by time complexity. Time complexity means the total time required to execute the program is nothing but time complexity. Okay. So, now big O notation generally used to say upper bound, omega is to say lower bound, theta is used to say in between upper and lower bound. That means average bound. Now, what are all these? What is big O? What is omega? What is theta notation? So, coming to first one, big O notation. Big O like this we will write, and it is denoted with O notation. Okay. So, what is this big O notation? So, f of n equal to big O of g of n if and only if f of n is less than or equal to c into g of n for all n, where c is constant, Okay. So, now what is the meaning of this? F of n equal to big O of g of n if and only if this f of n, whatever may be the function here, we are considering that f of n less than or equal to some constant into g of n. Okay. So, if this is satisfied, then we can say that f of n equal to big O of g of n. So, when we can say that f of n equal to big O of g of n, if and only if this condition satisfies. If this condition satisfies, f of n is less than or equal to c into g of n. If this satisfies, then we can say that f of n equal to big O of g of n. Let us discuss with examples. What is the meaning of this? What is f of n? What is g of n? What is c? What are all these things? Okay, let us discuss with some examples. For example, I have one function. That function is nothing but in terms of n or some constants we will get. Okay. So, suppose the function is 3n plus 2. You know how we will get this 3n plus 2? This 3n plus 2 already we discussed in step count method. In time complexity, in step count method we discussed for every step count will be incremented, and then we have to count the total number of steps. Then you will get the total number of steps like 3n plus 2. Okay. If you got a step count method like 3n plus 2, then we can say the time complexity as order of n. How can you say this? 3n plus 2 equal to order of n. How can we say this? So, now we can write like as 3n plus 2 we can write like less than or equal to c. 3n plus 2 is less than or equal to some 4n, where n is some greater than or equal to 2 you can consider. So, this 3n plus 2 on left hand side, it is less than or equal to 4n. this is our f of n. This is your constant c. This is g of n. F of n less than or equal to c into g of n. What can we say? We can say f of n equal to big O of, what is g of n here? G of n is n. That's why for 3n plus 2 we will write here order of n. This is one example. Hope it is clear. 3n plus 2 we can say that order of n is the complexity. Now consider another example. Take another function 3n plus 3. How can you say the time complexity in terms by using this asymptotic notation big O? This 3n plus 3 equal to, we can say that order of n only. When can we say that? So as 3n plus 3 is, 3n plus 3 is, so here big O notation less than or equal to f of n is less than or equal to 4n, where some n is greater than or equal to 3. Now, so how can you say like this? Same. Assume this is our f of n, no? And this is constant c into g of n, where c equal to 4 and g of n is nothing but n. So how can we say f of n equal to big O of, f of n equal to big O of g of n. What is g of n? n. Like this. So 3n plus 3 is nothing but, you can say that big O of n. Take another example. For example, now assume our function f of n is 10n square plus 4n plus 2. Okay. Then how can we say the time complexity in terms of asymptotic notations? Now that means what we have to identify? We have to identify what is c and we have to identify what is g of n. For this we can write like f of n. What is big O notation? F of n is less than or equal to c into g of n. Like this we have to write now. How can we write this? 10n square plus 4n plus 2 less than or equal to some constant c into g of n. Okay, less than or equal to, for example, we can say like some, that means what is this one? This function less than or equal to, that means right hand side should be greater, na? That's why here I am taking some bigger than this 10 and 11 n square, bigger than this, less than or equal to n square, for all n greater than or equal to 5. Okay, so now what is c here? C into g of n. G of n is nothing but n square. So f of n equal to, then what we can say? F of n equal to big O of g of n. That means big O of, what is our g of n? G of n is n square. So f of n equal to this one, then the time complexity is order of n square. Now, you know, generally in time complexities we will write like generally the order here it is first one we will write, after that log n we will write, and then we can write like n log n, the order generally n log n, after that we can write like n square, and then you can write n cube and so on. Like that we can write now. Okay, that means the smallest time complexity is constant. Later n log n we can write, after that you can write n log n we can write, after that n log n, after that n square, n cube, and so on. The maximum you can write like n power n. Okay, so now what is this big O notation? That big O notation is saying that upper bound of the given function. That means consider this example. For that we got upper bound as order of n square. You may get doubt like, madam, why should we take this 11n square? Can't we take 11n cube? Yeah, you can take. Can't we take 11n power 4? Yeah, you can take. That means upper bound may be order of n cube is also true. Order of n power 4 is also true. Order of n power 100 is also true. All these are true. Why? Because for this given function, the upper bound here it is order of n square. That means n square. This is upper bound. Na? Now this is n square and these are upper bounds for this. For this n square. Now we got this one n square. For all these you can take it as upper bounds. What are all these lower bounds? We can't write this order of n square. We can't write like order of log n, which is wrong. Why? Because these are lower bounds. So that's why you can write upper bounds on right hand side. Whatever you will get, all those things you can write. But all are true. Generally, which one we will consider is which is nearer or which is closer to the given one will be considered. Okay. So that's why f of n equal to, for this function, the time complexity is order of n square. What is this? Upper bound. Remember, all these are also correct. But nearer one we will consider. Okay. That means, for example, if you have another function like, take another example like 10n square plus 4n plus 2. The same function here I am taking. Na? For this you can write n power 200, which is correct. Which is correct. But it is not closer to the given one. That's why here we will take order of n square. Okay. So now. So this is big O notation. What is big O notation? Big O notation is upper bound of the given function. Big O notation tells upper bound for the given function. Next notation. Second one is omega notation. Omega notation. Omega notation, how to denote this omega notation? Omega notation is denoted with this symbol omega. Okay. What is this omega notation? So f of n equal to omega of g of n if and only if f of n is greater than or equal to c into g of n for all n where c is constant. So previously here we have written less than or equal to, here it is greater than or equal to. There it is saying upper bound and here it is saying lower bound. Lower bound for the given function. It tells about the lower bound. Okay. Now for this take some examples. For example, the function f of n equal to 3n plus 2. Okay. So now in this notation, omega notation, how can we say the time complexity? Okay. What is a lower? That means what is a lower bound for the function 3n plus 2? This is what is the upper bound for 10n square plus 4n plus 2. Upper bound for 10n square plus 4n plus 2 is order of n square. Of course, this is also correct, but we have taken closure one. Similarly, for the function f of n equal to 3n plus 2, what is the lower bound? What is the lower bound? So, now f of n equal to 3n plus 2 now. So, now that so in this form we have to write. So, 3n plus 2, that means f of n greater than or equal to, left hand side should be greater then right hand side. That is the meaning, no? This is LHS and this is RHS. Left hand side should be greater than or equal to right hand side. So 3n plus 2 greater than or equal to 3n, which is correct for all n greater than or equal to 1. So now what is C here? C into G of n. F of n greater than or equal to C into G of n. C into G of n. Then how can we write this? So then f of n equal to, simply we can write, which is equal to omega of, what is our G of n? G of n is n. So omega of n. Okay, is it clear? Hope it is easy to understand. If you understand big O notation, it is easy to understand this one. Okay, so let me take another example, like a 10n square plus 4n plus 2. 10n square plus 4n plus 2. For this, I want to represent a lower bound. What is the lower bound for the given function? Lower bound for this. Lower bound is 10n square plus 4n plus 2. Lower bound means f of n is greater than or equal to C into G of n. Okay, C into G of n. Simply I am writing some n square. For all n is greater than or equal to 1. Now left hand side is greater than or equal to right hand side. Yeah, it is correct. So it is satisfying this condition. So what is the lower bound for this? Lower bound for this is omega of n square. See, here I have mentioned for this n square, all these are lower bounds, all these are upper bounds. Here we will get a 2 power n also. Okay, so now see, so these are lower bounds, these are upper bounds. So for this n square, you can write omega of 1, which is correct, omega of n, which is correct, omega of log n, which is correct, omega of n log n, which is correct. But you can't write omega of n cube. Why? Because this is upper bound. Anything you can take, lower bounds. But as usual, so closure 1. Closure 1 for the given function will be considered. Closure 1 to the given function is n square. That's why lower bound of this function is omega of n square. For example, if we have another function like 6 into 2 power n plus n square. 6 into 2 power n plus n square. For example, if this is the case. Lower bound I want to say. Lower bound I want to say. So that lower bound is, you can take omega of 1 also you can take. Omega of n power 100 also you can take. Why? Because 2 power n is big na. Okay. So omega of n power 10 you can take. Omega of n also you can take. Okay. So which is all are correct here. Okay. So for this, all these are lower bounds only. Okay. So big O notation tells upper bound. Omega notation tells lower bound. Okay. Next, the last one is, another one here it is theta notation. Theta notation. This is denoted with the symbol theta. So now what is the definition of this notation? F of n equal to theta of g of n if and only if c1 into some g of n less than or equal to f of n less than or equal to c2 into g of n. So now if you observe this one, if you see this, this is f of n greater than or equal to c1 into g of n. What is this one? Upper bound. If you see this one, f of n is less than or equal to c into g of n. What is this one? Sorry, this is lower bound. F of n greater than or equal to f of n less than or equal to c into g of n is upper bound. So lower bound and upper bound. So both it is satisfying. So this is called as average bound. Okay, average bound for the given function. Both should satisfy here. So then that notation is called as theta notation. Okay, so now consider an example for this theta notation. For example, 3n plus 2. So f of n is 3n plus 2. For this, you can write like, this is f of n, 3n plus 2. So you have to write here this one, you have to write for this. 3n plus 2 is greater than or equal to 3n. Okay, 3n plus 2 is less than or equal to 4n. For the value of like n greater than or equal to 2. Now what happened here? See, 3n plus 2 is less than or equal to 3n, and here 3n plus 2 is greater than or equal to 3n. 3n plus 2 is less than or equal to 4n. So this is upper bound, this is lower bound. In between these two, so for this here we will get n, for this we will get lower bound is nothing but omega of n. Upper bound is nothing but big O of n. In between these two we can write theta of n. So theta of n is the average bound for the given function. So that means in between upper bound and lower bound. So we will mention it as a average bound. Average bound complexity or average bound for the given function 3n plus 2 is simply theta of n. Remember, here I am not saying like big O is upper bound and used to say the time complexity in worst case. I am not mentioning omega is a lower bound to denote was best case. So theta is average bound now. Okay, so it is not, I am not saying that this is like average case. Okay, so now these are the notations to say this given functions upper bounds, lower bounds and average bounds. That's it. So the time complexity you can say in terms of big O notation, omega notation, theta notation. You can say any one. If you are saying order of n, then which means that upper bound for the given function is order of n. If you are saying the same thing, omega of n, then lower bound for the given function is omega of n. If you have written like theta of n, then average bound for the given function is theta of n. It doesn't mean that like this is worst case and then this is a best case, this is like average case. It is not the case, don't confuse. Okay, so these are different notations used to say the boundaries, lower bound, upper bound for the given functions, or to say the time complexity, in these notations. So these notations are used big O, omega and theta. Hope you understand, students, all the asymptotic notations, big O, omega and theta notation. Okay. If you have any doubts, please send me your doubt in the comment box. If you understand the concept, please share with your friends. Okay. Thank you, students. Have a great day. Bye.